The question says carbon-14 is a radioactive element that decays to a half or a 2 to the power of negative 1 of its original amount after every 5,700 years. Determine the remaining mass of 10 grams of carbon-14, and they give us timelines. Question A, they want us to determine the mass of 10 grams after 1,400 years of decay. Okay, we'll just start with 1. Now we know that this element, or this radioactive element decays at a rate of a half or 2 to the negative 1. Now, is there any difference between those two numbers, 2 to the negative 1 and a half? No. 2 to the negative 1, we'll write it as a fraction in brackets. If I want to make this exponent positive, it becomes 1 over 2 to the power of 1, which is just 1 over 2. So 2 to the negative 1 is also just a half. So it doesn't really matter how we write this. We'll try solving it both ways. Now the second part of the question we have to figure out is we know that it decays that much after only 5,700 years. Okay? How many cycles of 5,700 years are in 11,400? 2. How would you find that? Do you know? Divide it. That's right. I divide 7,500 into 11,400. Some wonderful long division. I'm just going to let you know that the answer is 2. Goes in twice. Multiply that twice. Blah, blah, blah. Subtract, no remainder. Amazing. So we know that has 2 cycles of this 5,700 years. So there are 2 cycles of this rate of decay of a half or 2 to the negative 1. There are 2 cycles of that. So let's try to set up this question. I have 10 grams of carbon-14, and I know it decays at a rate of a half, or excuse me, let's write it as, we'll write it as a half. We're going to be multiplying negative 2 to the power of 1, and there's 2 cycles of it, okay? So we're multiplying these 2 numbers. 2 to the negative 1, we're going to change into our fraction. It becomes 1 over 2. We already solved that above. But it's still to the power of 2 on the outside. And we know we have to multiply by 10. I then square the half, which becomes 1 over 4, multiplied by 10. 10 over 4 is equal to 2.5. So after 11,400 years, there is 2.5 grams of carbon-14 left. Okay? Now, we changed this number into a half. Do you guys have any trouble on how I went from 2 to the power of negative 1 to a half? We'll do it on the side here. Pardon? Oh, that is a multiplication sign. Okay. 2 to the negative 1. Right? I need to make this positive. So I make this a fraction. Then I flip it. 1 over 2. Still to the power of 1. Well, half to the power of 1 is just a half. That's why I replaced that with a half when we moved it over here. Simeon. So the reason I put this to the power of 2, I should have mentioned, I put 2 to the negative 1 to the power of 2 because there were 2 cycles. Let's go to question B. Maybe it'll make a little more sense the second time around. Question B wants to know the exact same idea just after 28,500 years. First thing we're going to have to figure out is how many cycles is this going to go through. So I'm going to take 5,700 divided into this. It's going to go in 5 times. I actually did that in my head. So impressed with myself. So we know there are 5 cycles. So with those 5 cycles, let's try to set up our question. We know the rate of decay, 2 to the negative 1, multiplied, I won't use the dot this time, by the original 10 grams we started with. And we know there are 5 cycles. We put 2 to the negative 1 to the power of 5. Okay, let's try figuring it out this way. Maybe this will be a little clearer. I'm going to turn this 2 to the power of negative 1 into a positive exponent. Okay? Or actually, what I could do, before I do that, if we look at this rule here, if you guys remember our rules, I can multiply these 2 exponents. So these exponents are going to say 2 to the negative 5, power of 10. I still want to make this, sorry, did I do a number wrong? Okay, so what I did is I looked up our rules, remember from grade 9, way up here. Oh, no, it's on the wrong page. This rule, I used the rule of x, a, b. Remember when there's an exponent to the power of an exponent, it just becomes x, a times b. So I multiplied negative 1 by 5. Negative 1 times 5, negative 5. So I replaced the exponent with negative 5. Now I'm going to turn this into a positive exponent. I was using that one specifically. I got to turn this 2 into a fraction. Okay? So this becomes 1 over 2 to the power of 5 times 10. 1 over 2 to the power of 5 is the equivalent of 132 times 10. 10 over 32. What is 10 divided by 32 as a decimal? Anyone have a calculator on them? 0.3125. So, after 28,500 years, there is 0.3125 grams of carbon-14 left over. So 1 over 2 to the power of 5, I'm going to do it in disappearing ink. Ready? 1 over 2 times 1 over 2 times 1 over 2, 1 over 2, 1 over 2. I should not have done that in disappearing ink. 3, 4, 5. What's 1 times itself 5 times? 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 over 32. That's what I replaced it with right there. Does that make sense? Okay. Duke is getting very picky. There we go. 10 is in brackets. There you go, man. Anything else you guys need? So your homework for this very easy lesson, blue notebook, which is telling you to go into your textbook (202). Okay, I would also like you to do your review. Reviews on what page? Oh wait, that was the review. Sorry. That is the review, guys. What's the homework for tonight? No, that is part of the homework. 198. It's in Blue Notebook 117. Sorry about that, guys. Submit homework for tonight. I would like you guys to try to get as far as you can do the review, please.